In this video, we are going to find the prime factor of the number 512 cubed plus 675 cubed plus 720 cubed. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. My first step will be to find the prime factors of the three numbers at the base: 512, 675, and 720. So 512 is actually just 2 to the power 9, so 2 is the only prime factor. 675 is 3 times 15 squared, so 15 is 3 times 5, so we have 3 cubed times 5 squared. Well, 720 is 5 times 12 squared, and so we have 5 times 2 squared times 3 all squared, and that's 2 to the 4 times 3 squared times 5. So these are the prime factorization of the three numbers at the base. And we realize that they actually have very similar prime factors, but it's just that they do not have, there's no single prime factor that is common among all these three numbers. But still, I'll try to draw some connection between these three numbers. You may notice that if I square the third number, 720, the index of the prime factors 2, 3, and 5 will be much closer to those above. So notice that 720 squared is 2 to the power 8 times 3 to the power 4 times 5 squared. So the index for 5 is matched now, while for the indices of 2 and 3 is still a bit different. So to match them, I'm going to multiply an extra 2 with 720 squared. So then the index here becomes 9. Whereas for 512 times 675, we multiply that by 3. So we have half full again here. Now from this we know that some relation between the three numbers at the base will be 2 times 720 squared equals 3 times the product of the other two numbers. But we're not considering the cube, so I'm going to multiply both sides by another 720. So for the left we have a cube number. One of the terms at the top, one of the three terms, is equal to 3 times the product of the three numbers, all three numbers. Now here's a trick, is that we can recall the identity something about sum of cubes, is that for any numbers x, y, z, we can actually factorize their sum subtracted by 3 times all their product, and we get x plus y plus z times the sum of squares minus the mutual product. So now if I let x equals 512, y equals 675, and z equals 720, we may have something to obtain. However, If we just put them inside, of course, we will have sum of cubes minus 3 times the product of the three numbers. But we are just saying that we can factorize this expression. Which is actually not that useful. Because from this, we know that this group of numbers, after simplifying, we can find the prime factor. But we know that, on the other hand, from the relation above, over here, it is just equal to the sum of cubes minus 2 times 720 cubed, which is just keeping the first two terms the same, but for the last term it becomes a minus. So we need to come up with something else. Fortunately, if we change one of the substitutions, which means I'm going to change these signs from plus to minus and from minus to plus. Then we actually will have the sum of cubes, just like what we introduced above. That means from these operations, we know that this is the starting expression, and we know that I can rewrite that as this form. And this form, we know that can be factorized if we take x equals 512, y equals 675 like before, but for z, we change that as minus 720. So this is the motivation why we choose the negative number for z. At the same time, by multiplying all these numbers together, and then multiply by minus 3, we have a plus sign at the front of the last term. And from this, we know we can do the factorization. So this equals the first two numbers added together, while the third one is not plus 720, but is minus 720. Multiply by some other number. And so, by computing, we have 467 multiplied by some other number which is actually not important. Hard to compute without a calculator, but I know this is larger than 1. So that means it must be a composite number, because I can factor out into a product of two small numbers and both are larger than 1. In particular, this is a prime number, so that means one of the prime factors is this number 467. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.